No grouping the meters into one service connection is not permitted. The requirement for two separate service connections for a residential duplex building is typically found in the local building code or the National Electrical Code (NEC). Specifically, the NEC requires separate service connections for each dwelling unit in a multi-family dwelling. This is found in NEC Article 230.71, which states for each separate dwelling unit in a multifamily dwelling, an individual service shall be provided. The rationale for separate service connections is primarily for safety and maintenance purposes. Firstly, concerning safety, separate service connections provide a dedicated power source for each dwelling unit, reducing the risk of an outage or electrical hazard in one unit affecting the other unit. Secondly, regarding maintenance, separate service connections allow for easier maintenance and repairs by isolating electrical issues to a single dwelling unit. Because the building department has specifically requested two separate meters located on opposite sides of the structure, it is highly recommended to comply with this requirement. This will ensure that the building plan is approved and that the installation meets the required safety and code standards. Adhering to the National Electrical Code (NEC) is crucial when planning electrical installations, particularly in multi-family dwellings like duplexes. The NEC outlines specific requirements for service connections to ensure safety and facilitate maintenance. Understanding these requirements is vital for electrical contractors, builders, and property owners alike. One fundamental principle is the provision of separate service connections for each dwelling unit within a multi-family building. This is explicitly stated in NEC Article 230.71a. The primary reasons for mandating separate service connections revolve around enhancing safety and simplifying maintenance procedures. Let's delve into the importance of separate service connections for safety. When each dwelling unit has its own dedicated service connection, the risk of electrical faults or outages in one unit impacting the other is significantly reduced. For instance, if a short circuit occurs in one unit, it will only affect that unit's service, leaving the other unit unaffected. This isolation prevents the spread of electrical hazards and ensures continuous power supply to the unaffected unit. Now, let's examine the maintenance advantages of separate service connections. When each unit has its own service connection, troubleshooting and repairs become much easier. If there is an electrical problem in one unit, the electrician can isolate the issue to that specific service without disrupting the power supplied to the other unit. This targeted approach saves time, minimizes inconvenience for occupants, and allows for efficient maintenance operations. In contrast, if multiple dwelling units were connected to a single service, identifying and resolving electrical issues would be more complex and time-consuming. The electrician would need to isolate circuits and trace wiring to pinpoint the source of the problem, potentially causing disruptions to all units connected to the shared service. This scenario highlights the importance of separate service connections in streamlining maintenance procedures. To comply with NEC requirements, it is essential to ensure that each dwelling unit in a duplex has its own dedicated service entrance. This includes its own service disconnect, overcurrent protection, and metering equipment. The service entrance conductors must be sized appropriately to handle the electrical load of each unit, following the guidelines outlined in the NEC. It is also crucial to coordinate with a local utility company to establish separate accounts and metering for each dwelling unit. This ensures accurate billing and avoids disputes between tenants regarding electricity consumption. The building department's requirement for separate meters located on opposite sides of the structure reflects the importance of physical separation and independent metering for each unit. This arrangement further enhances safety and facilitates individual monitoring of electricity usage. When planning the electrical system for a duplex, it is advisable to consult with a qualified electrical engineer or contractor who is familiar with the NEC and local building codes. They can provide guidance on the appropriate service entrance size, conductor selection, overcurrent protection, and grounding requirements. They can also assist with the preparation of electrical plans and specifications that comply with all applicable regulations. During the installation process, it is essential to adhere to all safety precautions and follow the manufacturer's instructions for the electrical equipment being used. Only qualified electricians should perform electrical work, and all installations should be inspected by the local building department to ensure compliance with the NEC and local codes. Failure to comply with NEC requirements can result in costly rework, delays in project completion, and potential safety hazards. It is therefore crucial to prioritize compliance and ensure that all electrical installations meet the required standards. In addition to the NEC, local building codes may have additional requirements for electrical installations in duplexes. It is important to research and understand these local codes to ensure full compliance. For example, some jurisdictions may require specific types of wiring methods, grounding techniques, or surge protection devices. In summary, the NEC mandates separate service connections for each dwelling unit in a duplex to enhance safety and facilitate maintenance. Complying with this requirement ensures that electrical faults or outages in one unit do not affect the other, and it simplifies troubleshooting and repairs. When planning the electrical system for a duplex, it is essential to consult with qualified professionals, adhere to all safety precautions, and comply with both the NEC and local building codes. By following these guidelines, you can ensure a safe, reliable, and code-compliant electrical installation for your duplex. The NEC emphasis on separate service connections for each dwelling unit in a multi-family dwelling, like a duplex, stems from a deep understanding of electrical safety principles and the practical challenges of maintaining such systems. Let's explore these concepts further. Electrical systems, while providing essential power, can also pose significant risks if not properly designed, installed, and maintained. Fault currents, overloads, and installation failures can lead to electrical shocks, fires, and equipment damage. To mitigate these risks, the NEC establishes a comprehensive set of requirements for electrical installations. One of the key strategies for enhancing electrical safety is to limit the scope of potential problems. This is where the concept of separate service connections comes into play. By providing each dwelling unit with its own dedicated service, the NEC effectively isolates electrical issues within that unit. This prevents the spread of faults to other units and reduces the overall risk of a major electrical event. For example, if a faulty appliance in one unit causes a ground fault, the resulting fault current will be confined to that unit's service. The overcurrent protection device, such as a circuit breaker or fuse, will trip and disconnect the power to that unit, preventing further damage or injury. However, the other units connected to separate services will remain unaffected. In contrast, if multiple dwelling units were connected to a single service, a fault in one unit could potentially propagate to the other units, causing a widespread outage or even a fire. The NEC requirement for separate service connections also promotes better coordination of overcurrent protection devices. When each unit has its own service, the overcurrent protection devices can be sized and selected to provide optimal protection for the specific loads within that unit. This ensures that faults are cleared quickly and efficiently, minimizing the risk of damage or injury. Furthermore, separate service connections facilitate easier and safer maintenance. When an electrician needs to work on the electrical system in one unit, they can disconnect the power to that unit without affecting the other units. This eliminates the risk of accidental contact with live electrical components and allows the electrician to perform their work safely and efficiently. In addition to safety and maintenance benefits, separate service connections also simplify metering and billing. When each unit has its own meter, the utility company can accurately measure the electricity consumption of each unit and bill the occupants accordingly. This avoids disputes between tenants and ensures fair allocation of electricity costs. The NEC requirement for separate service connections is not limited to duplexes. It applies to all multi-family dwellings, including apartments, condominiums, and townhouses. The rationale behind this requirement is the same regardless of the type of dwelling. In some cases, the NEC may allow for a single service to supply multiple dwelling units, but only under very specific conditions. For example, if the dwelling units are located in the same building and are under single management, the NEC may permit a single service with individual submeters for each unit. However, even in these cases, The NEC requires that the service be sized to adequately handle the combined load of all the units, and that appropriate overcurrent protection be provided. The NEC requirements for service connections are constantly evolving to keep pace with changes in technology and industry practices. It is therefore important for electrical contractors, builders, and property owners to stay up to date on the latest code requirements. One way to do this is to attend continuing education courses and seminars offered by organizations such as the National Fire Protection Association (NFPA) and the International Association of Electrical Inspectors (IE). Another way to stay informed is to subscribe to industry publications and online resources that provide updates on code changes and best practices. In conclusion, the NEC mandate for separate service connections in duplexes and other multi-family dwellings is a critical safety measure. It helps to isolate electrical faults, facilitate maintenance, simplify metering, and ensure the reliable supply of power to each dwelling unit. By understanding and complying with the NEC requirements for service connections, you can help to create safer and more efficient electrical systems for your buildings. When dealing with electrical systems, especially in multi-unit dwellings like duplexes, understanding the nuances of the National Electrical Code (NEC) is paramount. The NEC isn't just a set of rules, it's a comprehensive guide designed to protect people and property from electrical hazards. The requirement for separate service connections, as outlined in NEC Article 230.71a, is a prime example of this protective approach. Let's break down why this separation is so crucial and what it entails. Firstly, consider the scenario of an electrical fault. In a duplex with a single service connection, a short circuit or ground fault in one unit could potentially affect the entire building. This could lead to a widespread power outage, damage to appliances, or even electrical fires. With separate service connections, however, each unit is isolated. If a fault occurs in one unit, it's contained within that unit's electrical system, minimizing the impact on the other unit. This isolation is not just about convenience, it's about safety. It prevents electrical problems from cascading throughout the building, reducing the risk of serious incidents. Secondly, maintenance becomes significantly easier with separate service connections. Imagine trying to troubleshoot an electrical issue in a duplex with a single service. You'd have to shut down power to the entire building, inconveniencing both tenants while you search for the problem. With separate services, you can isolate the electrical system of the affected unit, allowing the other tenant to continue using power uninterrupted. This targeted approach saves time, reduces disruption, and makes maintenance far more efficient. Thirdly, the NEC requirement for separate service connections also addresses the issue of equitable billing. Each unit in a duplex is responsible for its own electricity consumption. With separate meters and service connections, each tenant is billed accurately for their usage, avoiding disputes and ensuring fairness. This is particularly important in rental situations where tenants may have different energy consumption habits. Now let's delve into the practical implications of complying with NEC Article 230.71a. What does it actually mean to have separate service connections? Firstly, each unit must have its own service entrance. This includes the service conductors, the service disconnect, and the overcurrent protection devices, such as circuit breakers or fuses. The service entrance is the point where the utility's power supply connects to the building's electrical system. Secondly, each unit must have its own meter. The meter measures the amount of electricity consumed by the unit and is used by the utility company to calculate the bill. The meters should be located in an accessible location, such as on the exterior of the building, so that the utility company can read them easily. Thirdly, the service conductors must be sized appropriately to handle the electrical load of each unit. The NEC provides detailed guidelines for calculating the electrical load of a building, taking into account factors such as the size of the unit, the number of appliances, and the lighting fixtures. The service conductors must be large enough to carry the calculated load without overheating or causing voltage drop. Fourthly, the electrical system of each unit must be properly grounded. Grounding is a critical safety measure that provides a path for fault currents to flow back to the source, tripping the overcurrent protection devices and preventing electrical shocks. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. Fifthly, the electrical installation must comply with all other applicable requirements of the NEC and local building codes. This includes requirements for wiring methods, overcurrent protection, lighting, and appliance installation. It's essential to consult with a qualified electrical contractor or engineer to ensure that the electrical installation is code compliant. In addition to the technical requirements, there are also practical considerations to keep in mind when planning separate service connections for a duplex. Firstly, the location of the service entrances and meters should be carefully planned to ensure that they are accessible and aesthetically pleasing. The service entrances should be located in a place where they are protected from damage and weather, and the meters should be located in a place where they can be easily read. Secondly, the cost of installing separate service connections should be factored into the overall budget for the building. Separate service connections can be more expensive than a single service connection, but the long-term benefits of safety, convenience, and equitable billing outweigh the initial cost. Thirdly, the local utility company should be consulted early in the planning process to determine their requirements for service connections and metering. The utility company may have specific requirements for the location of the service entrances, the type of meters to be used, and the procedures for connecting the electrical system to the grid. Complying with these requirements is essential for ensuring a smooth and timely installation. In conclusion, the NEC requirement for separate service connections in duplexes is a vital safety measure that protects people and property from electrical hazards. By understanding the reasons behind this requirement and the practical implications of complying with it, you can ensure that your duplex is safe, efficient, and code compliant. Always consult with qualified professionals and adhere to all applicable codes and regulations when planning and installing electrical systems. Understanding the intricacies of the National Electrical Code, NEC, particularly regarding service connections for multi-family dwellings, requires a deeper dive into the technical aspects and practical considerations. Let's explore some key areas to provide a more comprehensive understanding. Firstly, let's discuss the service entrance. This is the point where the electrical power from the utility company enters the building. It consists of several components, including the service conductors, the service disconnect, and the overcurrent protection devices. The service conductors are the wires that carry the electrical current from the utility's transformer to the building's electrical system. The size of the service conductors is determined by the calculated electrical load of the building as specified in the NEC. The service disconnect is a switch or circuit breaker that allows the entire electrical service to be shut off in case of an emergency or for maintenance purposes. The service disconnect must be readily accessible and clearly labeled. The overcurrent protection devices, such as circuit breakers or fuses, protect the electrical system from overloads and short circuits. They are designed to trip and interrupt the flow of current if the current exceeds a safe level. Secondly, let's examine the metering equipment. The meter measures the amount of electricity consumed by the building and is used by the utility company to calculate the bill. In a duplex with separate service connections, each unit must have its own meter. The meters are typically located in the exterior of the building in an accessible location. The type of meter used depends on the voltage and current of the electrical service. There are two main types of meters: electromechanical meters and electronic meters. Electromechanical meters use a rotating disc to measure electricity consumption, while electronic meters use electronic sensors. Electronic meters are more accurate and can provide more detailed information about electricity usage. Thirdly, let's consider the grounding system. Grounding is a critical safety measure that provides a path for fault currents to flow back to the source, tripping the overcurrent protection devices and preventing electrical shocks. The grounding system consists of a grounding electrode, a grounding conductor, and bonding conductors. The grounding electrode is a metal rod or plate that is buried in the earth. The grounding conductor connects the grounding electrode to the service equipment. The bonding conductors connect all metal parts of the electrical system, such as metal conduit, metal enclosures, and metal appliance frames, to the grounding system. Fourthly, let's discuss the electrical load calculation. The electrical load calculation is the process of determining the amount of electrical power that a building is expected to use. The NEC provides detailed guidelines for calculating the electrical load, taking into account factors such as the size of the building, the number of appliances, and the lighting fixtures. The electrical load calculation is used to determine the size of the service conductors, the size of the overcurrent protection devices, and the size of the grounding system. Fifthly, let's address the wiring methods. The NEC specifies the approved wiring methods for different types of electrical installations. The wiring method refers to the type of cable or conduit used to run the electrical wires. Some common wiring methods include non-metallic sheet cable, rigid metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of wiring method depends on factors such as the environment, the voltage, and the type of building. Sixthly, let's delve into overcurrent protection. Overcurrent protection is a critical safety feature that protects the electrical system from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip and interrupt the flow of current if the current exceeds a safe level. Circuit breakers are resettable, while fuses must be replaced after they trip. The size of the overcurrent protection devices is determined by the ampacity of the conductors they are protecting. The NEC provides tables that specify the ampacity of different types of conductors. In addition to these technical aspects, there are also practical considerations to keep in mind when planning separate service connections for a duplex. Firstly, it's crucial to coordinate with the local utility company to determine their requirements for service connections and metering. The utility company may have specific requirements for the location of the service entrances, the type of meters to be used, and the procedures for connecting the electrical system to the grid. Secondly, the cost of installing separate service connections should be factored into the overall budget for the building. Separate service connections can be more expensive than a single service connection, but the long-term benefits of safety, convenience, and equitable billing outweigh the initial cost. Thirdly, the location of the service entrances and meters should be carefully planned to ensure that they are accessible and aesthetically pleasing. The service entrances should be located in a place where they are protected from damage and weather, and the meters should be located in a place where they can be easily read. Fourthly, it's essential to consult with a qualified electrical contractor or engineer to ensure that the electrical installation is code compliant. A qualified professional can help you navigate the complexities of the NEC and ensure that your electrical system is safe, efficient, and reliable. In conclusion, understanding the technical aspects and practical considerations of separate service connections for a duplex is essential for ensuring a safe, efficient, and code-compliant electrical installation. By paying attention to the details and consulting with qualified professionals, you can create an electrical system that meets the needs of your tenants and protects your property from electrical hazards. Remember, electrical safety is not just a matter of code compliance, it's a matter of life safety. When planning or modifying electrical systems, it is essential to consider various factors that can impact performance, safety, and compliance with relevant codes and standards. These factors include voltage drop, fault current, conductor ampacity, and grounding practices. A thorough understanding of these concepts is crucial for designing and installing electrical systems that are both safe and reliable. Firstly, let's discuss voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, reduce lighting levels, and increase energy consumption. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. The voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance. To minimize voltage drop, it is important to use conductors of adequate size and to keep the length of the conductors as short as possible. Secondly, let's examine fault current. Fault current is the amount of current that flows during a short circuit or ground fault. High fault currents can cause severe damage to equipment and can pose a significant safety hazard. The NEC requires that electrical systems be designed to withstand the available fault current. The available fault current can be calculated using engineering formulas and software tools. To protect against fault currents, it is important to use overcurrent protection devices, such as circuit breakers and fuses, that are rated to interrupt the available fault current. Thirdly, let's consider conductor ampacity. Conductor ampacity is the maximum amount of current that a conductor can carry safely without overheating. The NEC specifies the ampacity of different types of conductors based on their size, insulation type, and installation conditions. It is important to select conductors with adequate ampacity to handle the expected load. Overloading conductors can cause them to overheat, which can lead to insulation failure, fire, and equipment damage. Fourthly, let's discuss grounding practices. Grounding is a critical safety measure that provides a path for fault currents to flow back to the source, tripping the overcurrent protection devices and preventing electrical shocks. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding conductors. A properly installed grounding system is essential for ensuring electrical safety. In addition to these technical factors, it is also important to consider the environmental conditions in which the electrical system will be operating. Factors such as temperature, humidity, and corrosive atmospheres can affect the performance and longevity of electrical equipment. It is important to select equipment that is suitable for the environment in which it will be used. For example, in wet locations, it is important to use waterproof or rain-tight equipment. In corrosive atmospheres, it is important to use corrosion-resistant materials. Furthermore, it is essential to comply with all applicable codes and standards when designing and installing electrical systems. The NEC is the primary code for electrical installations in the United States. However, there may also be local codes and standards that apply. It is important to be familiar with all applicable codes and standards and to ensure that the electrical installation complies with them. Finally, it is important to use qualified and experienced electrical contractors and engineers to design and install electrical systems. Electrical work is inherently dangerous, and it should only be performed by those who are properly trained and qualified. A qualified electrical contractor or engineer can help you to ensure that your electrical system is safe, reliable, and code compliant. In conclusion, planning electrical systems involves careful consideration of various technical and environmental factors, as well as compliance with all applicable codes and standards. By paying attention to these details and using qualified professionals, you can ensure that your electrical system is safe, reliable, and efficient.